The alert looked routine, until the object ignored gravity. A harmless line of code from a deep sky system blinked across a monitor in the middle of a quiet night. Another faint mover, another dot on the star field. The name it picked up in the chatter didn't sound special either. 3i Atlas. Just a shorthand, a placeholder, something to call it while the world yawned. Then the numbers came in. The path that should have curved like every other rock in space began to drift, not because of Jupiter, not because of sunlight pushing on dust, because something nudged it, and that was the moment scientists stopped calling it a visitor and started whispering about an arrival. The next few minutes will take you through the discovery that shouldn't have been, the nudge that no rock should make, the alignment that feels planned, the silence that feels deliberate, and the theories no one wanted to speak out loud. And at the end, we'll face the question that matters, not what it is, but what we choose to do because of it. But first, let's rewind to where the code started to scream. It began the way these things always do, quietly. A Chilean observatory forwarded a routine alert, a string of characters flagged by an automated survey, the network that never sleeps, the mesh of sky cameras and wide-field telescopes that watch for the rare and the dangerous, had spotted a smudge sliding against the stars. Atlas in Hawaii had seen it first, barely there, caught between noise and signal. The follow-ups were cautious. Another exposure, another confirmation. Soon the nickname took hold in late-night emails and private Slack channels. 3i Atlas, third interstellar candidate. Not official yet, but sticky enough to spread. Speed told the first part of the story. It wasn't crawling like a long-period comet dropped from the Oort cloud. It was screaming, 40+ kilometers per second relative to the sun. A number in the range that gets astronomers to sit up straight. Not unprecedented. Oumuamua had done that. Borisov had done that. But always rare. Always a drumbeat that says, this thing came from somewhere else. The shape of the light curve, the way the brightness rose and fell, added a second note. Bigger than expected, or shinier, or both. Estimates shifted with every new data point, but the early math suggested we weren't looking at a pebble. Think city scale, not city block. Big enough to matter. Big enough to notice even when it was far out. Still cold, still dark, still anonymous. In normal times, that would have been the story. Third interstellar object. Press releases, neat diagrams, a few interviews about how lucky we are to live in an era when surveys find treasures like this. But the first oddity wasn't the speed or the size. It was the way the object refused to play the role it was given. Telescopes watched for the signs every textbook promises. As the sun warmed it, ices should have hissed to vapor. Dust should have peeled away. A tail should have bloomed and spread. Instead, nothing. Featureless. Clean. All signal, no fluff. A stubborn echo of Oumuamua's most frustrating habit. Act like a comet without looking like one. And yet this time, the stakes felt different. Because the next measurements didn't just challenge expectations, they broke them. But that wasn't the whole story. It looked like a comet. It refused to act like one. That was the drumbeat in the early days. Teams nudged their exposure times, stacked images, teased out every possible photon. If there was a coma, it was faint enough to hide from instruments that usually catch a whisper in a hurricane. Then someone noticed something uncomfortable in the residuals. The tiny differences between where the object should be and where it was. At first it smelled like a calibration glitch, maybe a timing offset, maybe atmospheric distortion in the raw frames. Every observer knows that a little math can make a faint object dance. So the community did what it always does when the data gets slippery. It slowed down. It pooled measurements. It cross-checked catalogs. It corrected for invisible things. Wind rush on a dome. Thermal drift in a sensor. The bias that creeps in at 3 in the morning when a human eyeballs a curve and hopes it fits. After the cleanup, the nudge remained. Here's why that's a problem. In space, motion is honest. Gravity writes the script and rocks read it. Comets can cheat a little because sunlight can heat their ices and turn them into jets. Tiny thrusters that push in odd directions. That's called non-gravitational acceleration. It's a known thing. But that trick leaves fingerprints. Spectral hints of water vapor, carbon monoxide, carbon dioxide, cyanides, dust. It leaves a glow. it leaves a mess. This object left a footprint without leaving mud. A few spectral scans came back with a strange tease, a reflective signature that didn't match simple ice or standard rock. Not an impossible reading, just a weird one. Still, weird is different from wrong. For a week, the consensus leaned toward patience. Let it come closer. Let the sun do its work. Let the coma bloom late. That's happened before. Then the third observatory saw the same sideways nudge at the same time. One measurement is noise, 2 is coincidence, 3 is a message. And what happened next rewrote the risk. Every orbital path is a promise. You gather points on the sky, fit a curve, and that curve tells you where the object will be tomorrow. The promise isn't poetic, it's math, it's precise, it's ruthless. When an object ignores the promise, something is pushing. The early deviation was small, milliarcseconds here, milliarcseconds there. Nothing dramatic to an untrained eye. But you don't need a big shove to reveal intent. You need a consistent one. Night after night, after cleaning out the noise, the offset piled up in the same direction, with the same timing. That alone didn't prove control. Comets hiccup, they sneeze, they cough out jets that make them twitch. But comets twitch messily, their pushes wander, their timing is irregular. Their spectra sing with the chemistry that did the pushing. Our object's push was neat. It was repeatable. It arrived like a heartbeat. That heartbeat did 2 things. First, it tightened the inbound course toward the ecliptic, the flat dance floor where the planets waltz. Second, it trimmed the time of arrival for a razor-close pass through the inner system. That combination set off alarms. Not public alarms, the kind that live in group chats with muted names, the kind that bounce between university addresses and .gov domains with words like contingency and assessment in the subject. If you want to know why, imagine a driver on a highway full of predictable traffic. Most cars move the same direction at the same speed. A stray boulder rolling down an off-ramp is dangerous, but at least it's blind. It doesn't aim. It doesn't pick a lane. Now picture that boulder spinning its wheels just enough to slide into the main flow at the perfect angle. Not a random bounce, a choice. Speed made the choice feel worse. 40+ kilometers per second is not just fast. It's fast in a way our tools aren't built to handle. Our most successful space hit so far, a test by slamming a spacecraft into an asteroid, worked because the target was slow, predictable, and known years in advance. Intercepting a city-scale object, dropping in hot from between the stars with weeks or months of warning, that's a different game. The difference between nudging a parked car and stopping a freight train. Teams on 3 continents tried to kill the hypothesis they didn't like. They tried to fit outgassing jets into the numbers. They tried to invent exotic ice that could blow without glowing. They pushed instrument systematics as far as honesty allowed. The cleanest solution still returned to the same place. The acceleration pattern looked deliberate. That doesn't mean intelligent, it means controlled. And control demands a mechanism. Where do you hide a thruster on something the size of a small city? You don't. Not at this distance. Not with this glare. You don't see it. You infer it. You watch what the path does. You listen to what the math says. And the math kept whispering the one thing no one wanted to put in a paper. Someone, or something, touched the wheel. It lined itself up with our cosmic boulevard. The ecliptic is the flattest, busiest plane we have, home to the planets, the swarms of asteroids, the dust that floats like breath in sunlight. A random interstellar rock dives through that sheet at any angle it pleases. This one flattened its approach until its path overlapped ours so cleanly you could lay a ruler on the sky and watch it trace the line. Chance can do that. Chance can do almost anything once. But chance rarely does it twice in the same direction, with the same quiet pressure, just when it matters most. The alignment alone would have raised eyebrows. The itinerary made jaws clench. The trajectory read like a curated museum tour. Maximize science return, maximize visibility, maximize options. Each projected flyby stole a little speed, or bent the path just enough to keep doors open all the way in. Pilots have a term for it: energy management. You don't waste fuel. You choose your moments. You arrive with what you need to do the job. One more detail pushed the pattern from unlikely to uncanny. It came in retrograde. Most of the solar system flows one way. This object sliced against the stream. That move raises relative speeds during close passes. It makes encounters more dramatic, and more useful if your plan is to deploy smaller craft that need a kick into orbit. It's also a terrible way to travel if you're a rock that doesn't care. Rocks waste nothing by following the herd. This object chose the hard lane, and it chose it with a precision that suggested it had done this before. Probability is a slippery friend in stories like this. You can multiply odds and get a number that looks impossible. That's not proof of intent, but patterns stack. Clues pile up. At some point, you stop asking whether each strange thing is an accident and start asking what all the strange things are trying to tell you. There was one more thing the pattern said, so loud that even the optimists heard it. The tour ended in our neighborhood, Earth-Moon country. Not a bullseye, but not a miss. A thread the needle passed through the space where tides rule and the intercept solution kept converging on us. You could feel the mood change in the cadence of the updates. Early reports read like weather forecasts, breezy, cautious, full of qualifiers. Then the language hardened. Converging solution. Consistent with directed maneuver. Cislunar passage within uncertainty wedge. No one wrote the words aimed or targeted in a public notice. They didn't have to. The plots said it. Inside agencies, a new kind of document made the rounds. Threat matrices with columns that included unknown intent, unknown capability, non-kinetic effects. Not because anyone had proof of weapons, because at these speeds and scales, intent alone is a capability. A city-scale mass changing its mind inside the orbit of Venus is a statement, even if the mass never touches anything. The other quiet change was who joined the calls. Radio astronomers, infrared specialists, orbital dynamicists, then operators who don't usually show up for comet meetings. Space surveillance networks with precise tracking of fast movers. Military space commands whose job is to know what crosses the sky and why. None of them issued press releases. None of them wanted to. But the signature of their attention was obvious. Distant galaxy observations were bumped. Targets with boring names were swapped for one with a nickname. A framework that had lived in a few scientists' heads for years became a spreadsheet row. Call it a technology likelihood index. Start at 0 for pure rock. Add points for non-gravitational acceleration without volatile signatures. Add points for alignment with the ecliptic. Add points for retrograde approach. Add points for precise timing through multiple encounters. Subtract points for any smell of a natural explanation. The score slid from uncomfortable to ugly in less than a week. If this was a comet, it was the tidiest comet in history. If it was a rock, it was the luckiest rock ever thrown. If it was neither, then we had to ask a question our species has never had to answer on a deadline. Maybe it's a machine that no longer remembers its makers. Maybe it's a neighbor who expects us to act like one.